In this video, we're going to cover 11.4, circumference and arc length. So the first thing we need to review exactly what is circumference, and that is just simply the distance around a circle. So if I start here and I go all the way around, that is the circumference of the circle. So then that leads us to arc length versus arc measure. Now, arc length is the portion of the circumference of a circle, so it's just part of it. The arc measure is the actual degrees. So I would like to use this picture here to explain this. If I ask you for the measure of the arc, it's going to look like the measure of arc RS. So that little m is going to stand for the measure of the arc. And that's always going to be in degrees. Now, if I ask you for the arc length, I'm actually asking for the highlighted portion. So the length of RS is not going to have the M. It's going to be a portion of the circumference. Now, I need you to know that that is going to be in linear units. So feet, inches, centimeters, it's not going to be in degrees. So now, theorem 11.8 is simply the circumference of a circle. The circumference C of a circle is pi times the diameter, or 2 times pi times the radius, since the radius, 2 of those make up the diameter. And D is the diameter and R is the radius. So if you've ever wondered where exactly pi comes from, pi actually comes from, we can see with this formula right here, if I divide both sides by D, I get circumference divided by diameter. That's actually where 3.14 comes from. So for us, pi in geometry is going to keep things exact. So we are always going to either leave pi in our answers, or we're going to use the pi on the calculator. I know in younger grades you use the 3.14 or 22/7, but for us we are going to actually use the pi key on the calculator. So exactly where is the pi key on your calculator? So if you have the TI, you can see over here below clear, there's that little pi key right there. So we would go second pi, and it's going to pop it up like that. And of course, it's going to tell you the pi number, but it's not going to round. So the calculator's always going to use the pi, the full-fledged number of it. So now this next part says find the indicated measure. And sometimes you'll be asked to round, to be asked to round, and sometimes you'll be asked for the exact answer. Now it's very important to keep the exact answer because that prevents round-off error. So number 1 says the circumference of a circle with radius 11 centimeters. So since it told us radius, we're going to use this formula. So circumference equals 2 pi r. So circumference is going to be 2 times pi times 11. So on the calculator, we would simply just type that in. Again, use that pi key. So 2 pi times 11. Round to the nearest hundredth, so we would say 69.12 meters. Now remember, this is linear units. It's how far apart or how long that piece is around the circle. Now the exact answer is actually easier. You just put the coefficients together, 22 pi. So 22 pi meters. So it's actually easier to give exact answers. Now the next one says the radius. Find the radius of a circle with circumference 18 yards. Now again, since it said radius, we are going to use the circumference is 2 pi r. Except this time it told us the circumference was 18. So 2 pi r. To solve for this, I'm going to divide both sides by 2 pi. Those are going to cancel out. And the radius is going to be 9 over pi equals r because the 18 and the 2 simplifies down to 9. So on the calculator, we would say 9 divided by pi. And we would simply say the radius equals 2.86 yards. But the exact answer would be 9/pi yards. Okay, and going to number 3, find the circumference of the circle with a diameter of 23. So since it switched to diameter, we're going to do pi d. And then we're going to say circumference equals 23 pi. That's going to be our exact answer. So that's going to be in inches. And then on the calculator, 23 pi is going to be 72.26 inches. So, in my opinion, exact answers are easier to deal with. And remember, we're not doing square units, we're not doing cubic units, because circumference is how far around it is on the circle. Now we're going to look at the arc length corollary. And it states, in a circle, the ratio of the length of the given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So it's saying the arc length, this part to the whole circumference, is equal to the measure of this arc to the whole 360 degrees. Or you can simply cross multiply and say that the arc length of AB is equal to the measure divided by 360 times its circumference. Now, I like to just remember this with a simple proportion. So, we call arc length in geometry a script L. So arc length is going to be a script L. So what this is saying is the arc length L over the circumference, 2 pi r, is equal to, we call this capital A, we're going to say that right there is going to be the degrees of the arc over 360 degrees. Now, the way that I would like for you to remember this is that this is the part, this is the whole. Just like this is the part over the whole degrees in a circle. Now, on this side, this one right here is dealing with the distance. And remember, this is in linear units. This side over here is dealing with the degree proportion. Now, it's going to be very important for you to understand that we're dealing with degrees, because in the next lesson we are going to be switching to radians. So, again, this is the arc length, this is circumference, this is the degree of the arc measure, this is the whole circle. So I think it's just easier to do it like this and then cross multiply, depending on what you're looking for. Now, moving on to number 4, it says find the arc length of AB. So we are looking for this distance, the arc length. So we simply set up our proportion. We are looking for arc length AB over the circumference 2 pi r, the r is 2, over the degree of the arc. The central angle is going to make this degree 88 degrees, and the circle has a total of 360 degrees. So we are going to cross multiply. The calculator is going to do all of the work for us. Remember to use the pi key, so I'm going to call this 4 pi times 88. And then I'm going to divide that by 360. And I'm going to get arc length is approximately 3.07 meters. So I can say that the length of arc AB is approximately 3.07 meters. So I think the proportion just helps you remember it. Part to whole circumference, part degree to whole degree. Now, question 5. Notice it switched to this M, so now it's asking us to find the measure of RS, not the length of RS, but the degree measure, if the radius is 12.3 feet. So it's only telling us the radius is 12.3. The picture, it kind of looks like the diameter, but the problem indicated that it was a radius. Now, we know this side over here is 38 feet. Okay, So RS, and it really didn't tell us, so actually I'm going to make this RS. Normally it would tell us that third, but since they're labeling that right there, 38, we're going to say that that is RS. So we know how long RS is in this picture. It's 38 feet. The circumference, we know the radius is 2 pi times 12.3, and that is equal to the degree, so I'm going to call that x, over 360 degrees. So again, I'm going to let the calculator do all of the work, so I'm going to cross multiply. So I'm going to say 38 times 360. And then I'm going to divide that, and I'm going to put in parentheses this expression because the calculator must do order of operations for us. If I do not put parentheses there, the calculator will not do order of operations. So this one right here, I'm going to now say that the measure of arc RS is approximately 177 degrees. And if you look at this picture, that looks accurate because it kind of looks like a diameter, but it's not. So it's 177 degrees because it's almost a semicircle. Now, moving on to question 6, it's now back to find the length of arc AB. So we're going to do the part over whole equals part over whole. We are looking for the arc length, so L goes to the circumference, 2 pi times R equals 97 degrees over 360 degrees. Again, cross multiply. 97 times 8 pi divided by that 360. So we're going to get the length of arc AB approximately 6.77 feet. Okay, and if you can compare that to that 4, and that's like 6.7, that picture looks accurate. Now, the last one on this page, it's asking now to find the circumference of circle Z. So notice that they're giving us different information every time, but that we don't really care about that. We've just got our proportion. This is telling me that the arc length is 3.44 centimeters. It's asking me for the circumference, so I'm just going to call that C for circumference. The arc measure is the central angle of 60, and this is 360. So, again, let the calculator do the work for us. 360 times 3.44, divide that by 60. That circumference is going to be about 20.64 centimeters, and it's actually going to be exact because there's no more decimals, so we'll say equals there. Now, where would this happen in real life? So question 8 is going to be a real life question, and it says a conveyor belt for luggage at an airport is shown at right. The outer part of the belt forms a 180-degree arc at each end. For each arc, the radius is 8 feet, so you can see that right here. Approximate the distance around the belt for the coin on the outer portion. So the first thing we need to realize, we are trying to find only the outer portion, so the outside. Now, if I chop this off here, and I chop this off here, and I color those in, hopefully you can see, if I take out that middle part, I would actually be forming a circle. So if I put these two together, I would be forming a circle. But we cannot forget about these two distances here either. So the easiest thing that we can do is if we find the circumference of this pink circle I have highlighted, and then I add 20 and 20, I would have the distance around the belt. So the first step I'm going to do is I'm going to do the circumference of the pink circles. So the circumference is 2 pi r. So we were told that the radius was 8. So the circumference is going to be 16 pi. Okay, so this is feet. And then I have 20 here, and I'm going to have 20 here. So that's going to be a total of 40 more feet. So if I add 16 pi plus 40, I am going to get almost 90 feet. So it says round to the nearest foot. So we are clearly just going to say about 90 feet since we are rounding to the nearest foot. So what that means is if the coin starts here and it travels all the way around back, it's going to be almost 90 feet. So in this video, we are going to stop here. So I'm going to go back over what we've talked about with these measurements. So I need you to remember L stands for arc length. The circumference is the whole. The arc measure to the whole measures. So if you will just set this proportion up every time and solve based on the information given.